Alright YouTube, welcome back to another Chem Complete episode, and today we are doing organic 2 material. We're going to focus on the end of the aldehyde ketone chapter and discuss the Wittig reaction today. So let's go ahead and get started with that and take a look at the mechanism and the mechanics involved in the Wittig reaction. So the Wittig reaction is usually broken down into two parts, and the first part you actually have to create is the reagent that will be used in the Wittig reaction. Similar to a Grignard reaction where you had to create the Grignard reagent and then you could use it with an aldehyde or ketone, the same holds true for the Wittig reaction. We're going to create the actual compound that will react with the aldehyde or ketone, and that is known as an Ylide, and that's pronounced with an I, not a Y, even though this is how it's spelled. It's Ylide. And the Ylide will react with the aldehyde or ketone of choice, and it will end up giving you an alkene at the end. So let's talk about how to first develop Ylides. So the first thing that we are going to pick out is some sort of alkyl halide. You usually want a methyl, a primary. You occasionally may attempt to do a non-sterically hindered secondary alkyl halide. However, this is generally considered to be an SN2 type reaction, and the Wittig reaction itself is limited in the amount of sterics it can handle. So you don't want to go too crazy with your alkyl halides here. So we'll just do an ethyl group. That's a nice primary alkyl halide. You want a good halogen on there for leaving group. And then the other thing you are going to mix with is triphenylphosphine. And hopefully you remember phenyl is a benzene ring. So you're going to see me write this in this fashion most of the time. In fact, all the time, because I'm not always going to draw this out. But I will show you for one time's sake. Here's your phenyl group, right? And I've got a phosphorus. And so if I'm talking about two additional phenyl groups, then I would have triphenylphosphine would be something like this. Fairly bulky reagent itself. So again, you're going to limit the sterics of the alkyl halide. But this is what your reagent looks like. And to create the Ylide, there's really two steps. This is the first step. You're going to undergo a substitution reaction in which you will kick the leaving group off and substitute the phosphorus in. Now keep in mind that here the phosphorus was neutral. So once you have completed this, that phosphorus is going to take on a positive charge because it donated its electrons. All right, so that's CH2, and then I've got phosphorus with a positive charge, and it still has the 3 phenyl groups attached to it, right? So the next step that we're going to have here is in step 2, you will take that compound, that substitution compound, and you will expose it to butyl lithium. Now, butyl lithium is a butyl group, so 4-membered chain, and the end of that chain forms a carbanion, which is a very strong base. This is a dangerous reagent if you're not used to using it. It's pyrophoric, meaning if you take it up in a syringe and then you inject it into the air, it will completely combust and catch on fire immediately as it leaves the syringe. So this is stabilized somewhat with the lithium ion. All right, so that's butyl lithium. Sometimes you may see it called N-butyl lithium, like this. The N just means normal, as in normal chained, because you could have isobutyl, sec-butyl, all of those types of things. So it's specifying that it's just a normal chain butyl. So what we're going to do with this, and you'll see why I explicitly draw out these hydrogens in a second. Here's the reagent that we just came off of making. Right? So if I expose this to the butyl lithium, where the butyl group really contains a negative charge because it's a carbanion, this will very readily, it's such a strong base, it will readily go over and pick off one of these hydrogens, and these electrons from the hydrogen-carbon bond will go to the carbon, and that will create a sort of carbanion complex, like so. And this right here is the Ylide. We've now created the Ylide right here. So somewhat similar to when we had a Grignard, right? You had some sort of R group and then MgBr, partial positive for the metal, partial negative for this. I would argue this is an even larger separation of charge than the Grignard is. You can really view this as negative and positive here when you look at the mechanics and the electronics of the mechanism. And so I've got this portion right here, this CH group, is going to be an excellent nucleophile. And so that'll go in after aldehydes and ketones. Now that I have my Ylide formed, I can use that Ylide. All right, so I'm going to clear the page here. And give me a second. All right, so let's clear. And let's take a look at the actual Wittig reaction itself now that we've done that. So I'm going to bring my Ylide back, and I'm going to say, let's start with a ketone. We'll just start with something like acetone. It's fairly simple. Okay, now some of these reactions we've seen with aldehydes and ketones recently, we've protonated the oxygen first because there's some sort of acidic conditions. There are not going to be any acidic conditions when we do this Wittig reaction. In fact, just the opposite. This is rather basic in nature, just like a Grignard would be. And so we will go straight for attacking the carbonyl instead of doing any sort of protonation and activation of the carbonyl group beforehand. And instances where we did see that was like the acetyl formations and the enamines and imine formations and things of that nature. So here's my Ylide. With my Ylide, it's going to, this portion, this carbanion, is going to come and attack the carbonyl group, which of course will push these electrons up just as it would in a Grignard reaction. Because the carbon cannot have more than 5 bonds, we can't violate the tetrahedral nature of carbon at any time. That would supersede the valence laws. Okay, so then, now the way I like to do this, and you'll see why in a second because of the intermediate, I usually like to take whatever was on the right of my aldehyde or ketone and swing it down into this position right here. Okay, and that's because this reagent is going to interact with the oxygen, so we kind of want to set it up there. So what I've got here is I've got the CH and the CH3, and then this right here would be the phosphorus triphenyl. And you can see why you write the triphenyl in this fashion instead of drawing out the rings. It would be enormous and it would take up way too much space on a test or homework or anything like that. Not to mention if you're on a test, that's an excessive amount of time to keep drawing those out. So usually just writing pH. Sometimes phenols are represented like this with a slash through them. That's probably a sloppy slash, kind of like this. Okay, just so you are aware if you've seen it. And so that oxygen is negative. This setup hopefully is very evident as to what's going to happen. You've got a excess set of electrons right next to the phosphorus. And so they will be donated over here. And what we end up with, this is sort of a special intermediate. It's a 4-membered intermediate. The only other major time that we've seen a 4-membered, and it wasn't even intermediate, it was a transition state, was with the boron trihydride, which was a anti-Markovnikov hydration addition. All right, so we've got this 4-membered intermediate state. It's kind of unique here. Oops, that's not R. That's P. And pH3. So at this point, this group right here has a special name. It is referred to as betaine. That's how you would pronounce it. Beta, like the Greek letter beta, and then add an ene at the end of it. This is a betaine. This is an important intermediate in this reaction. The 4-membered ring is relatively unstable due to angle strain, and so it will collapse on itself to deliver the final compound here. And the way that this ends up going is that these electrons will fold down into an alkene bond, and these electrons will fold up between the oxygen and the phosphorus. And hopefully you could see what may come out of this if you were looking at it. If you have a double bond there, you're going to get an alkene as your main compound. I'm going to need a little space here, so let me move my talking head over. Let's put it, where should we put it? Right down here. That works. Okay, so we've got the CH3, right? And then we've got this C. We still have this CH3 here. And then I would have a double bond to a CH3. Right? So what I have essentially created, not essentially, I have created an alkene. And there is a side product that will always come out of this, and that is triphenylphosphine oxide. Okay, so you're not normally going to see me draw this because, again, it is a side product that's not really of a whole lot of interest to us. We're primarily after the carbon organic reagent that we've created, which is this right here. So you can create alkenes. And note that the alkene really took the place of the carbonyl group, right? So that, if that was an O, this would still be acetone. And so that is the Wittig reaction. The Wittig reaction takes these Ylide reagents, it uses them in order to create alkenes by going through that four-membered betaine intermediate state and kicking off the relatively stable phosphorus triphenyl oxide as one of the side products, and you get the alkene as your main product there. So let me clear this. I'm going to give two examples here. So let's go ahead. We will do one that contains an aldehyde. I think that's good because remember this chapter is aldehydes and ketones. So let's do benzaldehyde. That will be the aldehyde. And then let's use for the Ylide, what shall we use? Let's just do a CH2 minus PPH3. Okay, so that's the Ylide. So what would the compound or the product be there? And then for this one, I'm going to make the second one a little bit more complicated. All right, so for this one, we'll do a ketone again. Make it a little more complicated this time, but the main point is that you've got this ketone functionality here that's going to interact, right? And so what I'm going to do this time, instead of directly handing you the Ylide, let's say, okay, so number one, what if I did, here we'll do something along these lines, CH2, CH2I with PH3. Number two, this was exposed to butyl lithium. Okay. And then number three, whatever comes out of that is actually reacted with this. So maybe I should have put this out front and then the others there. But you get the main idea, right? So go ahead and try these. Pause the video as usual and then come back and we will discuss the answer. So I'll see you guys in just a second. Go ahead and try these. I'm going to move my window while you do that. All right. So hopefully you were able to complete these syntheses. So right here for the benzaldehyde, I would have something that looks like this. So I have the CH, and then it would be double bonded to a CH2 like that. Okay, you can show this H coming off separately if you want to. It doesn't really matter, but that is the general compound you should have had. And so for this guy right here, let's draw it up this way this time. I should see something along the lines of this, right? Whoops, that's not right. I made that an isopropyl group. All right. So there you go, guys. That is the Wittig reaction. Keep in mind, you need to create your Ylides using primary, maybe some non-sterically hindered secondary alkyl halides. You could certainly use a methyl. Along with triphenylphosphine, you have to expose it to the butyl lithium in order to make the Ylide itself. Then react with aldehydes and ketones, and you'll get alkenes as the resulting product. So hopefully you guys found this useful. Please remember to like the video if you found it helpful. Any comments I will be happy to get back to as soon as possible. I'm happy to address any questions if you're confused about something that you went over in lecture with your instructor and you need clarification. Other than that, I would ask you to subscribe if you found this video useful, because you will get all the up-to-date information as I release videos and organize my playlists. That also helps out the channel a lot, because I do this on my spare time to try to help you guys out, and it helps me a lot if you support the channel. So please remember, like the video, comment, and subscribe, and I will see you guys for the next lecture, where we will talk about alpha beta unsaturated ketones and aldehydes. So I will see you guys there, and have a good one.